Hello and welcome to another video. Today we will be talking about Linux and Windows permissions. So without further ado, let's get to it. So let's begin by talking about Linux permissions. And Linux permissions are a fundamental aspect of the system's security and management, controlling user access to files and directories. The traditional model is based on assigning to files three different permission categories of users. These three categories are the owner, as you can see here, the group, and others. Each of these categories can have different levels of access to files and directories that are defined by read, write, and execute. So let's relate each category of users to their respective levels of permissions. So, the owner is typically the creator of the files and directories. The owner has the authority to set permissions for themselves, the group, and others. Then we have group. This consists of a set of users who are assigned to a group that can share the same permissions. Each file and directory is associated with one group. And we have others. These are users who have access to the system but do not own the file and do not belong to the group to which the file is assigned. Now, when we discuss permissions, it's important to know that they are not spelled out fully, such as read, write, or execute. Instead, they are represented by letters. So, the read permission is represented by an R, as you can see here on the screen. The write permission is represented by a W, as you can see. And the execute permission is represented by an X, as you can see here. In taking this example here on the screen, if we look at the owner's permissions, we can see that the presence of an R, this one here, indicates that the owner can list the contents of this directory. If there were a dash instead of a D, it would signify that this is a file, not a directory, and the owner could read the contents of that file. So, with this here, you can see if this is a directory with a D, or if it's a file with a dash, okay? And because the owner has a W, it means that the owner can add, remove, or rename files within this directory. If this were a file, the owner would have permission to modify its contents, okay? The X means that the owner has permission to enter the directory and access files and subdirectories contained within it. If this were a file, it would mean that the owner could execute the file as a program or script. Now be aware that all these permissions can be applied to the group and others as well. The permissions are often represented as a string of characters. For instance, this permission here, as you can see, means for the owner that he can read, write, and execute the file. In this case, it's a directory. For the group, that the group can read and execute, and for the others, that they can't do anything because they don't have an R or a W or an X, okay? However, permissions can also be represented numerically using octal numbers, like so. So the number 4 stands for read, the number 2 stands for write, and the number 1 stands for execute. So when we have a file with the permissions R, W, and X, numerically these permissions are represented by a 7 because 4 plus 2 plus 1 is 7. So for instance, a file with these permissions could be represented as 7, 5, 4. 7 for the owner, as you can see here, 5 for the group, and 4 for the others. 7 for the owner because he can read, write, and execute, so you need to sum all these here, that will give 7. 5 for the group because the group can read and execute, and 4 plus 1 gives 5, and 4 for the others because they can only read, okay? Now I will show you in my Kali Linux what happens when a user tries to read a file that he does not have permissions to read, and what happens when he tries to change of directories when he does not have permissions to do that. So I'm 𝑑𝒆𝒓𝒔𝒕𝒂𝒏𝒅𝒊𝒏𝒈. and if I run the command who am I, you will see that I'm 𝑠𝒏𝒏𝒈, and I am the owner of all the files and directories that are inside of this directory called permissions, as you can see here. So when I use the command ls-l, I will have access to information such as the permissions for the files and directories here, who owns the files and directories, the name of the group that has access to those files and directories, the name of the files and directories, the size of the files and directories, and the date and time when the files or directories were last modified. As you can see, because I'm 𝒏𝒏𝒈, I have access to all these files and directories. You can see it here on the permissions. Now, I created a new user called tester, and this user can see the contents of the directory permissions, so this one here, because he has permissions to do that. But from these files here and their permissions, what do you think that will happen if the tester user tries to see the contents of the file example.txt? What do you think that will happen? Well, let's see. I will switch from my account to the tester's account, and I will try to read the file example.txt. I will use the sudo command -u tester bash. This command starts a new bash shell session under the user identity tester. This means that any commands you type in this new shell will be executed as if you were the user tester, not as your current user, so not as 𝒏𝒏𝒈. Also, it's helpful to remember that the bash shell is the program running inside the terminal that processes and executes the commands you type. Click enter, insert the password, and if you run the command who am I, you will see that here I am the tester, okay? So here I'm 𝒏𝒏𝒈, but here I'm tester. Now let's list what's inside of the permissions directory, just for you to see that the user tester can see all the files and directories inside of permissions directory because he has permissions for that. ls-l. So as you can see, the tester user can see all the files inside of permissions because he has the permission to see all the files. But now let's try to read the contents of the file example.txt. So cat example.txt. Okay, as you can see, the user tester can't see the contents because he does not have permission for that. Now, if you look here at 𝒏𝒏𝒈 account, you will see that the tester user can't access the directory called 𝒏𝒅𝒔𝒕𝒂𝒏𝒅 because if you see here in the others group, they can't see anything, they can't write anything, and they can't execute anything. And our tester user belongs to the others, okay? So if you go back to the tester's account and try to change of directories to the 𝒏𝒅𝒔𝒕𝒂𝒏𝒅 directory, you will see that the tester can't do it because he does not have permissions for that. So let's try it anyway. So cd, that stands for change directory, and then the name of the directory examp-dir. And as you can see, the permission was denied because it does not have any permission to read or execute, okay? One thing that is important to tell you is that if you want to see what groups you are a member of, you can use the command groups, so let's use it here. But as you can see, it does not belong to the group 𝒏𝒏𝒈, so it does not belong to this group that is associated with these files and directories, so these files here in directories. Otherwise, when we run the command groups on the tester shell, we should see not only the group called tester, but the group called 𝒏𝒏𝒈. Since it does not belong to the 𝒏𝒏𝒈 group, regarding these files and directories here, it falls into the others category, okay? So now you know how to see permissions, how they look like, how you can verify the groups that you belong to, among other things. Now let's see two ways that we can use to change file permissions. So to change file permissions we need to use the command chmod, that stands for change mode. However, what comes next is what changes. So we can change file permissions using their numerical representation, which I talked about at the beginning of this video. And let's do that to a file that our tester user can see the contents of. So we already know that he can see the contents of the file example.txt. Now let's give to the tester permission to read the file example.txt, but using numbers. So do you remember what is the number that represents the read permission? Well, the number is 4. So the command will be like so. Chmod 754 and then the name of the file, in our case is example.txt. But before we execute this command here, when we have this permission string, numerically it's represented as 750, okay? Because it's 7 for the owner, because he can read, write and execute. It's 5 for the group, because the group can read and execute, and it's 0 because the others can't do anything. So now let's run the command and see if the others now can read the file, okay? Okay, as you can see now, the others can read the file. So let's read the file as a tester. We go to tester bash, we insert the command cat, and then example.txt. And as you can see, we can now read the file example.txt, okay? Before we couldn't do that, as you can see here, but now we can, because we gave the group permissions the permission to read. Now, let's change the permissions of the directory called 𝒏𝒅𝒔𝒕𝒂𝒏𝒅 so that the tester can change to this directory and read its contents. However, we are going to use the other way, where we use letters instead of numbers. So, we use the command chmod, then O plus RX, and then the name of the directory, 𝒏𝒅𝒔𝒕𝒂𝒏𝒅. In this command, the O stands for others because the user tester falls into the others category. The plus is used to add permissions, and the R and X are the permissions that we want to grant to the others category, which includes tester. Now you click enter, we insert the command ls-l to see if the permissions were changed to the others category, okay? And as you can see, now the others category can read and execute the _dir directory. Now, let me just tell you that if instead of adding permissions, if you want to revoke permissions, you can use the minus signal. So, instead of a plus, you can insert a minus, okay? Also, if you want to change the permissions for the owner, you can switch this O here with a U that stands for user, that is the same as owner. If you want to change the permissions for the group, you use a G, so it will be like this, and for all, you can use an A, okay? Now let's go to the tester bash shell and change of directories to see if we can do it. So cd _dir, and as you can see, we are now inside of the _dir directory. Remember that we couldn't do that before, but now we can. So let's list what's inside of _dir directory, okay? L&S, and here we have other directory and a file called file2.txt. And that's it for Linux permissions. Now let's talk about Windows permissions. Windows permissions are a crucial part of Windows security architecture, designed to control access to resources such as files, folders, and printers on a network or on individual PCs. These permissions are based primarily on access control lists, aka ACLs, which specify which users or system processes can access certain resources and what actions they can perform with those resources. Now we have two main types of permissions in Windows. So we have NTFS permissions and share permissions. But let's first talk about NTFS permissions. So, NTFS permissions, also known as New Technology File System Permissions, determine the level of access that users and groups have to files and folders. These permissions can be set to allow or deny different types of access by different users or groups. The primary types of permissions that can be set on files and folders within NTFS are full control. Users can read, write, execute, change permissions, and take ownership of the file or folder. We have the modify permission, and this permission allows users to read, write, execute, and delete the file or folder. We have the read and execute permission, and this permission allows users to run executable files and view file contents and attributes. We have also the read permission that lets users view file contents and attributes but cannot change the file in any way. And we have the write permission. This permission lets users add files to directories or write to a file but cannot delete files, okay? Now, to assign NTFS permissions, you can right-click on a file or folder, select Properties, go to the Security tab, and click Edit to change permissions, or Advanced for special permissions, or Advanced settings. If you are asking yourselves what's the difference between basic permissions and advanced permissions, is that basic permissions are broader and more general. They are designed to be easier to manage and apply, making them suitable for most standard security situations. Advanced permissions allow for more specific control over what actions can be taken, making them ideal for complex security environments where different users or groups might need highly customized access levels. I will click on Edit, and here you can add or remove users and groups and specify the appropriate permissions using checkboxes or through a more detailed interface, but that it's in the case that you click on Advanced, okay? So I click Edit, and I will add a new user just for you to see how I do. So I click Add. So I want to find users from the location 𝑑𝒆𝒓𝒔𝒕𝒂𝒏𝒅 and then the name of the user. In my case, the user is called Tester101. Okay, check name. Our Windows found my user. Then I click OK, and then I click Apply, and then OK. And like this, I added my Tester101 user. Now, there is something that we need to talk about because it's very important to know, and that is the permissions inheritance. So, what is permission inheritance? Imagine you have a folder on your computer called example, like me. Now, when you set up permissions for this example folder, you are essentially deciding who can access this folder and what they can do with it, like reading files, modifying them, or even deleting them. Windows permission inheritance ensures that any new files or subfolders you create inside the example folder will automatically have the same permissions as the parent folder. So, if you create any file or a subfolder inside of the example folder, those files or folders will have the same permissions as the example folder because the example folder is the parent folder. Now, this is helpful because it saves you a lot of time and effort. Without inheritance, you'd have to manually set permissions for each new file or folder you create, which can be tedious and prone to errors, especially in a busy work environment. Now let's say you create a file called example.txt inside the example folder. By default, example.txt inherits all the permissions from the example folder. But what if you need to restrict access to this file beyond what's set for the whole folder? Well, Windows makes this easy. You can modify the file's permission directly, tailoring access without affecting the parent folder's settings. This flexibility means you can have general rules for most of your content, with specific exceptions as needed. But remember, if you ever need a folder or a file to stop inheriting permissions, that's possible too. You can disable inheritance and set up independent permissions. This is particularly useful for sensitive documents that require restricted access. So, as you can see, understanding and using permissions inheritance effectively can streamline how you manage security on your Windows system, making it both simpler and more robust. Keep this in mind as you organize your files and folders, and you'll find managing access a much smoother process. Now, let me just tell you that if you want to disable inheritance, you can go to Advanced and click Disable Inheritance, okay? It's that simple. Well, that's it for NTFS permissions. Now let's talk about the share permissions. Well, share permissions are applied to a folder and all the files within it that is shared over a network. These permissions control what actions different users can perform on the folder and its contents when they access it over the network. So, to access these share permissions, you do the same that you did for the NTFS permissions, but instead of clicking on the Security tab, you click on Sharing tab. Then you click on Advanced Sharing. You check the box that says Share this folder, and you can also change the share name if you want. The share name is the name that network users will see. Click on the Permissions button to set the share permissions for the folder, so you click here. You can modify the permissions by selecting Everyone, so selecting this here, or adding a new user or group by clicking Add. So you click Add if you want to add a new user. For instance, let me add my user tester101. Check name, as you can see, my Windows could find my tester101 user. You click OK. Then you click Apply. As you can see, my user is now here. And now you click once again OK. Now you click OK in the Advanced Sharing, so this is the Advanced Sharing, and click Close on the Folder Properties window, like this. And that's it for the share permissions, okay? Now you ask, but what's the difference between Linux and Windows when it comes to managing permissions for files in directories? Well, Linux permissions are straightforward. They group users into 3 categories: the person who owns the file, the group that owns the file, and everyone else. This system works well for most situations where you don't need verify detailed rules about who can do what. Now, Windows permissions, however, are more detailed. They allow you to set specific rules for each person using the system. You can decide exactly what each person can do with files and folders, like whether they can look at, change, or delete things. And this is especially useful in big companies where different people need different levels of access to information. Well guys, that's it for now. I hope that this video helped you in any way possible. If you have any questions, please leave those questions in the commentary section down below. See you next time, stay curious, stay safe, and keep exploring. Bye bye!